Here we go, guys. Last example for gas stoichiometry. This one's a good one to look at. It's got a couple of other little wrinkles to it that you should be paying attention to in future stoichiometry problems. First problem here is that you're dealing with a volume in mils, much like in question 3 where we had megaliters. All right, you can convert that into scientific notation and just go to straight liters, which is nice. Or we can remember from previous examples that the metric system will survive the problem and we can convert that later. So maybe I'll show you what that looks like if we don't change units, and we'll go from there. The other issue here is that all of your given information has been the stuff about the random conditions of the gas. Don't forget that 8.314 kilopascal liters per mole Kelvin is one of the parts of any universal gas law problem or situation in which you do not have a standard STP or SCTP problem. So I like to begin there. And here's why. All of the units that you could ever want are found in the universal gas constant. And I know that I need moles to get there. What do I start with first out of these guys here if I'm trying to get moles before I can do stoichiometry? Well, it's probably this guy right here that I want to begin with. And you'll notice that if I flip that fraction, moles will be in the numerator exactly where I want them. So there we go, 8.314 kilopascal liters, but oops, I'm flipping the fraction. So moles and Kelvin are in the numerator, and there's that mole that I want. This is not too dissimilar to some of the beginning problems we did in gravimetric, where I started with molar mass rather than the given information, because in the end, before I can do stoich, you want to have moles as your last remaining unit. With universal gas problems, ideal gas problems, the universal gas constant is a great starting point because it offers everything you need. So now I just need to cancel out Kelvin, kilopascals, and liters, and oh my goodness, I have all of those already. So kilopascals, I'll put those in the numerator. Kelvin, I'll put that down here, and you can see that it is 298 Kelvin, and it is 94.9 kilopascals. So Kelvin go, kilopascals go, and now I've got moles per liter. Fantastic. I have liters here. And so we get 787 milliliters. And so the liter will go. And now I'm in millimoles, which is just a metric version, smaller version of the mole. That's fine. I'm only showing you this here just to remind you that we did talk about this in the past, in which the metric system survives the problem. You're still in millimoles of your oxygen gas, and so now I can go to my mole fraction here. I have oxygen gas that I want to get rid of, and I want to get to magnesium oxide. You can see from that mole fraction here that it's 2 parts magnesium oxide to 1 part oxygen. And oxygen now leaves the problem that I forgot to write earlier on. No big deal. And now we have millimoles of magnesium oxide. That's wonderful. I want to get to grams. So I can go straight to my molar mass and watch what happens. Moles on the top need to cancel out by going on the bottom. Grams go here. And for every 1 mole of magnesium oxide, what we have is, what is that going to be? 40.31? Missing a periodic table. I'm going to assume that's correct. And it's 24.31 for magnesium, 16 for oxygen. That should be correct. And so moles now go, and you have milligrams, which is a mass of magnesium oxide. If you don't like that, we can certainly turn that into grams, but it is a valid amount here that we can use. And so it just takes us running through our calculator. Remember that numerators are multipliers, so I would probably do 94.9 times 787 times 2 times 40.31, and I'll divide that by 8.314. I'll divide that again by 298, and I get 2,430.28, pardon my notation there, of milligrams. So I can turn that into grams. I'm just going to make it a little bit bigger here. And so I get 3 digits throughout, 2.43 grams of my magnesium oxide produced in this particular example. Okay, there you go. That's a bunch of examples that take us through all of that stuff we did in gas laws back in chapter 4. I hope it is clear and understood to you guys now. Again, try 294 to 296. That's really important. Try some questions on 296 and 298. Do as many as you need to understand this concept well enough. Okay, get rid of the pre-lab for 7.3. We certainly can't be doing that one. But good luck with the practice problems. And one more topic to go. We just have to get through Solution Stoich in 7.4.